Hi, and welcome to my room. My name is HAMZA JAMSHAID, and today I'll be giving you a presentation on my project, which is my IBM Advanced Data Science Capstone project, and the topic is human activity recognition using the data that has been collected from the gyroscope and accelerometer in a smartphone. Hello, and welcome to our Advanced Data Science Capstone project presentation. Here's an outline of what we'll be doing in a presentation. The first thing we'll do is discuss about the data set, the use case. Then we'll explore the data. Then we'll define our model. We'll select the most optimal model. We'll also make a deep learning model. And finally, we'll evaluate that deep learning model. Our data set has been published by the Smart Lab Laboratories from the University of Genoa, Italy. It contains 10,000 rows of data, each row having 561 features. The data has been classified into 6 different types of activities, namely walking, standing, sitting, etc. Now this data has been encoded as integers from 1 to 6. Our use case is that a user's activity would be recorded using the sensors of a smartphone. This activity would be logged in the mobile phone and would be classified into different types of activities. This could later be monitored or viewed by the user in order to find out his daily or monthly activity. The solutions for our problem could be either using the classification algorithms like the nearest neighbor, the state vector model, extra tree, random forest, or we could make a deep learning model. In this case, we'll be using a sequential model with a single hidden layer. Now, our data set has been derived using the three-dimensional signals of a gyroscope and an accelerometer sensor in a smartphone. This data has been pre-processed to create these 561 features. Here is an overview of our exploration notebook. For this purpose, here is a list of libraries we'll be using. First of all is Pandas, then NumPy, then Matplot library, and Seaborn. Matplot library and Seaborn are both graph libraries. Well, Pandas would help us convert the dataset into a data frame. The first thing we do is we import the dataset into a data frame of name x_train. We're reading the dataset from a CSV file. Now, as our first step in the exploration process is that we check for missing values or null values. For that purpose, I'm going to take the training set and use the method isNull. This method would return the number of null values in a single column. Now I've sum all those values. As output, we see that starting from the first column and up to the last column, we have 0 or no null values in our data set. We apply the same procedure on the target data set, that is our Y column or our training column. The column name is activity, and also for this column we have 0 null values. Now, as the second step in our exploratory process is that we'll try to we'll plot a histogram of the activity based on the count or the recordings per activity. To make the graph more understandable, we'd convert our labels or encoded labels from integers back into strings. This would be done using the replace method. For example, I decoded 1 to walking. Now we'll plot the distribution of data for each category of activity. We count the number of activities per column. Then we decide the figure size. And finally, we plot the histogram. The histogram shows us that the most data we have recorded is for the activity labeled as laying, which is like you lying on your bed or you're lying just for it. And the activity with the least is walking downstairs. Here is the final step of our exploratory process or the data exploration process. Since we're dealing with a data that has more than 500 columns or features, we'd like to find out the variance between these features. And to do that, we'd use the principal component analysis method or the PCA method from the scikit-learn library. The first thing I would do is I'd fit the principal component analysis on the training data. After training, I would like to plot a graph for the principal component analysis. Here is the plotted graph of the principal component analysis. From this graph, it is visible that after 200 components, starting with here, our variance is very high, almost 98%, and this increases to a peak value at 250 or almost 250 principal components. This was the last step in our exploratory process. Now we know how we can optimize our data set for better model. Here is the overview of our model using scikit. The first thing we'll do is we'll apply standard normalization or standard scaling to the data. Then we'll apply a principal component analysis. Finally, we train our model and then evaluate it. Here, we import all the models from the scikit-learn library. Like from the tree, we import the decision tree classifier, and from neighbors, we import the neighbor classifier. From naive Bayes, we take Gaussian. From ensemble learning, we take Bayesian classifier, random forest, extra tree, and gradient boosting classifier. We again pre-process our data sets and convert them into NumPy arrays, and we flatten our label arrays, that is our Y or our target columns, into a single dimensional array. Here we create or define our models. For neighbors, we are taking 7 as the components or neighbors. For Bayesian classifier, we are taking 100 estimators. For random forest, we are taking 1000 estimators. Now we fit all these models on the training data. After completing our training, now we'd like to test the accuracy of our model on the test data. For that, we use the score method and we print the results. Starting from the nearest neighbor up to the gradient boosted, we have printed all the results. The methods or the models with the highest accuracy are the extra tree classifier, boosted trees, and the state vector model. For improvement purposes, we are going to take the state vector model and we are going to improve its accuracy from 94% to 95%. For that, we come to feature processing. First, we apply principal component analysis. Then the first thing we're going to do is we're going to apply scaling to the data. Then we are going to reduce the components using principal component analysis. Here we fit the principal component analysis function and the scaling function on the training data. After fitting the principal component analysis, we can see that number of optimum components would be 250. So we fit our principal component analysis again on 250 components. First, we apply scaling on our data. Then we apply principal component analysis. And here we retrain our state vector model on this processed data. We now evaluate this newer model and we see that the accuracy is now 95.04%. To evaluate our model, we are going to import the confusion matrix from the matrix library. This confusion matrix plots the true positives along with the true negatives, the false positives, and the false negatives. We also import the classification report. This is a very important method as it explains to us the precision, recall, and F1 score of each of these individual classes. We have used precision as a method for evaluation because precision explains us better about the correctly predicted classes and the wrongly predicted classes or the misclassified classes. Since our problem is a multi-classification data, we need to find the precision for each of these classes. So for instance, we can see that our class labeled as 5 has the least precision with 92.7%. From this metric, we can easily analyze from the precision method. We can easily find that this class has the least precision, and we can improve this precision by either adding more data for this specific class or again using the feature processing. The F1 score also provides us with similar information but with little difference. It helps us identify the true positives, the true negatives, the false positives, and the false negatives. Now let's discuss the deep learning method that we are going to use. The first thing I'm going to do is I'm going to create a sequential model. Then I'm going to add a dense layer of 220 input dimension, since we have reduced our data using the principal component analysis. An important thing to do before creating deep learning model is that we need the Keras library. We import sequential and dense methods. Now we build our model. The first thing we'll do is that we create a sequential model. Now we add the input layer with 220 inputs. Then we create our hidden layer with 512 nodes. For activation, we are using softmax. To compile our model, as loss we are going to take mean squared error, and for optimizer we'll take ADAM. Our metric would be accuracy. We'll train the model for 50 epochs. At the beginning, our first cycle shows a 0% accuracy and a very high loss. After 10 epochs, we manage to get an accuracy of 32%. This keeps on going to 90% at the 20th cycle. And at the end, we have a whopping figure of 99.5%. Now we evaluate our neural network based on the test data. And for test data, we have an accuracy of 95.28%. I've also brought a summary of the neural network. This explains us about the layer, the first layer which has an input of 220, the second layer which has an input of 512. Notice that the input shape or the output shape is an array. Our total parameters for the neural network are 162,000, and all of these parameters are trainable. So at the end, we'd like to say that we have successfully achieved 95% accuracy using both conventional and deep learning algorithms. For deployment purposes, we deploy our model as a smartphone application. But before that, we'll try to improve our accuracy up to 97%. You can also contribute to our project by downloading our public repository. The link is given below. If you want to learn or are interested about human activity recognition, you can refer to these 3 links that I have mentioned. So that was it for Capstone project presentation. Hope you guys learned from it. If you guys have any comments, you can leave that in the comments section for the video. So that's it. Have a good day.